Hello, today we're going to start section 3.1, Introduction to Word Problems. The objectives of today are to model a verbal scenario as a linear equation and inequality, set up and solve a word problem, including defining variables, model objectives and conditions, as well as interpreting the solution. Part 1, Translating Words to Math. We've seen some examples of how we can translate words into math. Let's remind ourselves of some of these translations below. Is and other verbs indicate equals. Addition is indicated by phrases like sum of or more than. Subtraction is indicated by phrases like difference of or less than. Multiplication is indicated by phrases like product of or times. Division is indicated by phrases like quotient of or ratio. Less than is indicated by phrase is less than and has fewer, whereas less than or equal to is indicated with phrases like is no more than or is at most. Greater than is indicated by phrases like is greater than and is more than, whereas greater than or equal to is indicated with phrases like is no less than and is at least. Notice the being verb included in all of the inequality phrase. Without it, such phrases as more than or less than indicate addition or subtraction. Unknowns take the form of variables like x or y, but you can also have s or t, etc. Example 1. Translate the following words into equations. 3 times a number plus 2 means equals 17. Or equivalently, just write 3x plus 2 equals 17 instead of 3 times x plus 2 equals 17. The quotient of. Now, whenever I see one of these words with the word of, I automatically look for the word and, because that is where the division symbol will go. So that goes for the sum of, difference of, or product of, and is where that operation will go. The reason why it's division here is because of the word quotient. So the quotient of a number and 2 is at least, so that's greater than or equal to 57. Or equivalently, we could have wrote y over 2 is greater than or equal to 57. The difference between two numbers, so this time I have two numbers, so let's use w minus z, that's the difference between two numbers, is less than 7. Double the sum of. Now here, there is no word and, so it seems like I lied to you. But the reason why there isn't is because it says two numbers. It could have said one number and one number, but they simplified it to two numbers. That's why there is no and in this example. So the sum of two numbers, so let's x plus y, we need to double that. So that means multiply it by 2. Now, since we're doubling the sum and not just doubling a number, you do need to put parentheses around the sum. And then is, now it says the second number, so y plus 10. And that's how we can translate words into equations or inequalities. Part 2, word problems. Word problems, I'm sure you've seen in previous classes, there's many ways to enumerate what these steps are. This is one way of doing it. So step 1, before anything, ask yourself, what is the problem about? Draw a picture if possible. In order to do this step, you may need to read the question 2, 3, 4 times, maybe even. 2, what's the question? Use it to help define any variables or unknowns. 3, translate words into math starting from the beginning, if possible. 4, check to make sure that what you've written makes sense with what the problem says. 5, solve and check mathematically. 6, check to see if your answer makes sense. Example 2. A student has grades of 78, 66, and 87 on the first 3 exams in a mathematics course. What does the student need on the 4th exam to obtain an average of 80? So I understand what's going on. There is no geometry, no tree, no ramp, nothing like that where I can actually draw something. So I can't draw something. So next, let's indicate what our variables are. Well, our variables are based off the question, what does the student need on the 4th exam? So I'm going to say the grade of the 4th exam is, let's use X. Now that I've identified what the variable is, we need to understand what we're looking for, and we're looking for an average. So this requires us to know what the formula for the average is. So to find the average of exams, you just take the scores, add them together, divide by how many there are. So we have 78 plus 66 plus 87 for the first 3 exams. But now that I've said that the 4th exam is X, I get to add X to that. And then since there were 4 exams, we divide by 4, and I want this to equal 80. Now we want to go through and solve this for X. Well, because there's a fraction, the first thing we're going to do is clear the denominators by multiplying both sides by 4. So then we get 78 plus 66 plus 87 plus X equals, well, 4 times 0 is 0, 4 times 8 is 32, so 320. Next, I'm going to combine like terms. So 7 plus 8 is 15, plus 6 is 21. Carry the 2, plus 8 is 10, plus 6 is 16, plus 7 is 23. So we get 231 plus X equals 320. And then to solve for X, we subtract 231. So X is equal to 9, 8. So this means we need an 89 on the 4th exam to get an average of 80. Example 3. A photographer intends to enlarge a photograph so that the enlarged photo has a length of 18 inches. If the length of the enlarged photo is 3 inches less than 4 times the original length, what should the original length be? Again, this one, you could draw a picture, but it doesn't say if it's a rectangle or a square. It doesn't give us much information, so I can't see a way to draw a picture for this one. But It does have an unknown, and what that unknown is the original length. So I'm going to say the original length is x for this problem. Now this one, instead of having a formula like the average formula, it gives us a sentence in which we can translate into English. The sentence is, length of the enlarged photo is 3 inches less than 4 times the original length. So the length of the enlarged photo is 18 inches, so we get 18. Is means equal to 3 inches less than. So that doesn't mean 3 minus. When I say like 5 less than 7, that means 7 minus 5. So that means I'm going to have to go minus 3. Okay, so 3 inches less than means minus 3. And then 4 times, so that means I have to go 4 times the original length, which we said was x. So we get 4x. So this is the equation we get from translating the sentence into math. Now we solve for x. So we add 3 to both sides. So we get 21 equals 4x, divide by 4, divide by 4. So x is 21 over 4 because that can't be reduced. And since we're talking about inches, that's 21 over 4 inches. Now, I am a fan of fractions, but usually when we're talking about inches, decimals are preferred. So let me do the long division to convert this to a decimal. How many times does 4 go into 21? Well, it goes 5 times. So then we get 5 times 4 is 20. Subtract 1. Oh, need another place, so I add a decimal, drop a 0. 4 goes into 10 twice. Get 8. 2. Oh, I need another 0. Drop that down. And then 4 goes into 25 times. So then we get a remainder of 0, so we're done. So that means x is also 5.25 inches. So that's what the original length was. And that is it for part 1 of section 3.1.